I've got another function that's quadratic in form. This would be a quadratic in cosecant, because I've got some cosecants and some cosecants squared here. Okay. So when I have that, I know I want to try factoring. And before I factor, I've got to have everything on one side set equal to 0. So I'm going to start by subtracting over that 3. So we'll have 2 cosecant squared x minus 5 cosecant x minus 3 equals 0. Now, when I have 1, 2, 3 terms like that in a quadratic expression, I'm really hoping that this is the result of FOILing. I'm going to just record that it's still equal to 0, so I don't think that I'm done once I've factored. But that means I'm hoping that I can break this up into a product of 2 binomials. And I usually just do a little bit of sort of systematic trial and error. If the first terms are going to multiply to give me 2 cosecant squared, I'm going to need to have a 2 cosecant of x and a cosecant of x. So I'm going to go ahead and just put those in place. And then I'm going to jump to the last term. I need those numbers, the numbers that I put here, to multiply to give me negative 3. So if it's going to factor nicely in terms of integers, it's going to have to be a 1 and a 3, with one of them positive and one of them negative. And so then I just want to figure out where do I put them and which one is positive and which one is negative. Okay. Well, if I put the 3 here and the 1 here, the outsides would be 2 cosecant, the insides would be 3 cosecant, but they're going to have opposite signs. I want them to subtract to give me that middle term. 3 and 2 don't subtract to give me a negative 5. If I put the 3 here, that's going to give me 6 cosecant. I'd have to put the 1 here, that's 1. Ooh, I'm liking that. 6 cosecants and 1 cosecant, that can subtract to give me the 5. And if I want to get a negative 5, looks like I want the bigger one to be negative. So let's just do a quick check. First terms give me 2 cosecant squared. Outsides are negative 6 cosecant. Insides are plus cosecant. That gives me a total of negative 5 cosecant of x. And then the last terms multiply to give me negative 3. Fabulous. Okay. So now I can set each factor equal to 0. So 2 cosecant of x plus 1 equals 0, or cosecant of x minus 3 equals 0. And for both of those, I want to just isolate the trig function. So here, this would become cosecant of x equals negative 1/2, and this would become cosecant of x equals 3. Now, I can see that one of these is going to have no solution. If you can see that from here, great. I prefer, whether there are solutions or not, I prefer to work with sines rather than cosecant. So I'm actually going to rewrite both of these in terms of sign. This would say sine of x, that's taking the reciprocal of this side, would be the reciprocal of this side would equal negative 2. Now, I think it's a little easier to see that that has no solutions than that that has no solutions. Can see it either way, but I know sine can only take on values between negative 1 and 1. Cosecant, on the other hand, only takes on values 1 and bigger, or negative 1 and smaller. Either way, the number I have is not in the range of the appropriate trig function. So this has no solution here. Any solutions are going to come from this one. And I'm going to just write this in its more familiar form. The reciprocal of cosecant is sine. The reciprocal of 3 would be 1/3. So we're looking for angles whose sine is 1/3. Now that is between negative 1 and 1, so I'm going to have some solutions. So let's think quadrants. Sine is positive in quadrant 1 and quadrant 2. Okay. So if sine x is 1/3, I'm not talking about a nice reference angle of pi over 6 or pi over 4 or pi over 3. So my acute angle here will just be x is arcsine of 1/3. Okay. I could have expressed that as arc cosecant of 3. That would be another way of giving that answer. I usually prefer to write things in terms of sines, cosines, and tangents. Okay. Here, that's going to become my reference angle. So x is pi minus alpha. That's pi minus arcsine of 1/3. So those are my two solutions. They're both solutions that make this factor equal 0. There's no angle that makes that first factor equal 0. Okay. So we've just got arcsine of 1/3 and pi minus arcsine of 1/3. And then for all solutions, I'm just adding a multiple of the period. And whether I'm thinking in terms of cosecants or thinking in terms of sines, they have the same period. It's 2 pi. So we will have arcsine of 1/3 plus 2 pi n, and pi minus arcsine of 1/3 plus 2 pi n, where n is an integer. That will give us all solutions to this particular equation.